Hello. Right. So we will be for today's class. We'll be entering the very last chapter of chapter 5, which is the normal approximation. Okay, we already talked about it a bit yesterday. So let's talk in depth about it today. So there's two different. Okay, first of all, why do we use a normal approximation? Okay, so for example, if we have a different kind of distribution, like for example a binomial distribution or a Poisson distribution, and if the random variable, the value of n or the value of mean is very large, okay, we can use a normal approximation. Because if we did not use any kind of approximation, uh, it will be very hard for you to calculate. Okay, so that's why we use a normal approximation. Normal approximation works better the bigger the number of n. Okay, so first of all, let's take a look at normal approximation of the binomial distribution. Okay, so for the binomial distribution, we can approximate to normal distribution if we have a large n multiplied by p. Okay, if we multiply n with p, we'll get a value of more than 5. If this is the case, then we can use a normal approximation. Okay. If you remember, we learned on the previous chapter, if n multiplied by p is less than 5, then we can approximate using Poisson. Okay, but in this case, if n multiplied by p is more than or equal to 5, then we can approximate using a normal distribution. Okay, so that's the difference. So if we approximate using normal distribution, then x, okay, x is any kind of variable, will follow a normal distribution with mu equal to np and standard variance equal to n multiplied by p multiplied by 1 minus p. Okay, this will be your value of variance. Okay, that's for if you want to approximate binomial distribution. We can also approximate a Poisson distribution. Okay, if you have a very large value for the lambda, okay, lambda is, remember, it is the average. Okay, if the value of lambda is large, such as lambda is more than 20, then we can approximate x using a normal distribution as well. So how do we approximate it? Okay, so x will follow a normal distribution with mean lambda, okay, with mean lambda and also variance equal to lambda. Okay, so again, this one, if we want to approximate a Poisson distribution, okay, a Poisson distribution for a very large value of lambda. Okay, and for both of these situation, if we want to approximate either binomial distribution or a Poisson distribution, we need to do something. Okay, this is very important because usually students will forget about this step. Okay, so the step that I meant is to use a thing called continuous correction factor. Continuous correction factor. So why do we need to do a continuous correction factor? Because if you see here, we have a Poisson distribution and also a binomial distribution. These two distributions are discrete distribution. And now we want to approximate them, convert them into a normal distribution, which is a continuous distribution. So that's why from moving from discrete to continuous, we need to do some correction. Okay, because for discrete, you only have countable numbers, right? Like for example, 0, 1, 2, 3, 4, 5, 6, and so on. Okay, but for continuous, there's like an infinite number between 0 and 1. Okay, you can have 0 0.005, 0 0.00321, and then 0.9999 and so on. Okay, there's a lot of numbers between 0 and 1 and stuff. But for discrete, there's only 0 and 1. Okay, so that's why we need to do this kind of correction. So how do we do the correction? Is that, okay, we call it as a continuity correction. Right. So, okay, this is what I just explained. Okay, so here's how you do it. Okay, I don't want you to memorize all of this thing. what I want to do is to understand the concept behind it. Okay, so if you understand the concept, you don't need to memorize like, oh, if s less than or equal to a, it will become a plus 0.5 and so on. Okay, because this will be very tiring to memorize everything. So the concept here that say that you have a number. Okay, say that you have a number in your book. This one on page 133. Okay, say that you have a number. Let's say the number is 6. Okay, then here we have 5. Here we have 7 and so on lah. Okay, this one is 8. This one is 4 and so on here and so on here as well. Okay, so what is a continuity correction factor is that for all discrete values, you will need to add n plus 0.5. Means, say that we are looking at x equal to 6. So we need to add plus n minus 0.5, which means 6 minus 0.5 is 5.5. So here is 5.5, and 6 plus 0.5 is 6.5. Okay, so for x equal to 6, if we do a continuity correction factor, it will become 5.5 until 6.5. This is the new range for value x equal to 6. Okay? So this is what we call as continuity correction factor. Okay, so that's the continuity correction for number 1. And then for number 2 until number 7 here, you just utilize that properties. Okay, for example, if we want to find px less than a, okay, px less than a or less than or equal to a lah. So here, if you have, say that we want to find px less than or equal to 6. If px less than or equal to 6, which means the number that it can take, okay, for discrete is 6 and below. So 6, 6, 5, 4, 3, 2, 1, and so on. So to convert it into a continuous, we know that number 6 is included. So if we do a continuity for number 6, okay, continuity correction for number 6, we will include 6.5. Okay, because remember for number 6, we need to add n minus. So for x less than or equal to 6, it will equal to probability of x less than 6.5. Okay, again, because we are including 6. Okay, x less than or equal to 6 means that 6 and below. So 6, 5, 4, 3, 2, 1. So to convert it into a continuous variable, so we need to include 6.5. Okay, what if it's let's get another color. What if it's probability of x less than 6? So for x less than 6, for discrete variable, what is the number that it can take? So it can take 5, 4, 3, 2, 1, 0. Okay, not including 6. So if it is not including 6, so it means that it started with 5. 5, 4, 3, 2, 1. Okay, so if you start with number 5, remember that for continuity correction factor, you need to add n minus 0.5. Which means that for x equal to 5, you need to add n minus 0.5. So if we minus, it will become 4.5. If we plus, it will become 5.5 over here, 5.5. Which means if we want to find probability of x less than 6, it will become probability of x less than 5.5. Okay, so this is the concept. Okay, similarly lah, for number 4, 5, 6, and 7. Okay, honestly, I don't really care about whether it becomes, because here is like more than, and then here is more, sorry, here is more than or equal to, and here is more than, right? But honestly, because it's continuous, you don't really care that much about whether it is more than or more than or equal to in continuous. But in discrete, like for example, here, if it is x less than or equal to 6, means that you need to include 6. So, which means the continuity correction factor will be x less than 6.5. If x less than 6 in discrete, which means it only will take 5, 4, 3 to 1, okay, without including 6. So the continuity correction will be 5.5. Okay, that's the concept. Okay, you can extend this into uh, x more than or equal to 6, x more than 6, okay? And also when the number is in between like this. Okay, it's the same concept. Okay, if, for example, right, if I want to find the probability of x when x is between 3 and 7, like for example, if I want to find this value, so what does this value of x take? So x only take 4, 5, and 6. Okay, it does not include 3 and 7 because see here is less than, not less than or equal to, which means on a number line, if we have 3, 4, 5, 6, 7, okay, so it only includes 4, 5, and 6. So for number 4, only you need to remember that you need to add or minus 0.5. So here should be 3.5. Okay, and then we take 4, 5, and 6. So 5 as well, and then 6 as well. Okay, we don't take number 7. So here 6 would be 6.5, which means if you want to do the continuity correction for this one, it will become the probability of 3.5 x 6.5. Okay, so this is the concept of continuity correction. Okay, all right. So quite long. Let's take a look at an example. Okay, this is your example in the book on page 133. Suppose a fair coin is tossed 60 times. Okay, and then find the probability that find the probability between 28 and 33 times head will appear. Okay, so here we have a fair coin. So you know that a fair coin, we have a probability of head is equal to 0.5. And it is tossed 60 times. So this is your n. So first of all, you already see that this number of n is very big. Okay? Number of n is 60, which is way bigger than you usually do. But you know that this is a binomial distribution. Okay. Now if x equal to number of head, then you know that x will follow a binomial distribution of 60, n equal to 60, and the probability of success, in this case getting head, is 0.5. Okay, but here is 60. Okay, 60 number of trials, which is very big. So what we can do is we can approximate using a normal distribution. So to approximate using a normal distribution, if you see in your notes again, okay, so check n multiplied by pi, okay, n multiplied by pi. So here will be 60 multiplied by 0.5. So here will be 30. So 30 is more than 5. So it means that we can use a normal distribution to approximate this binomial distribution. So x now will follow a normal distribution of mean is equal to n multiplied by pi. So n multiplied by pi is 30. So we have mean equal to 30. And the standard deviation of n multiplied by pi multiplied by 1 minus pi. So we have a standard deviation of n multiplied by pi multiplied by 1 minus 0.5. So here you will get the answer of 15. So here will be 15. Okay. Remember that this 15 is your variance. Okay. That's your variance. Okay, next, if we want to find the probability between 28 and 33 times head will appear, so let's write it down. The probability between 28 and 33. Remember that we are moving from a discrete distribution, which is binomial distribution, to a continuous distribution, which is normal distribution. Okay, so what we need to do is to do a continuity correction factor. Okay, to do continuity correction. So here, we know that 28 is not included and 33 is also not included. So if you draw a number line, 28, 29, 30, 31, 32, and 33. Oh, 30. So we only include 29, 30, 31, and 32. So if we do a continuity correction for 29, we will need to minus 0.5. So here will be 28.5. And then for 32, we need to plus 0.5 here. So it will become 32.5. Okay, which means we need to find the probability of 28.5 up until 32.5. Okay, is this region. Okay, so this is how we do a continuity correction. So from now on, we can just continue as we did in the last class. So here, of course, we need to change x into z first. Means the probability of 28.5 minus, okay, remember that x now follow a normal distribution with mean 30 and variance of 15. So to find z, so x minus mu, so mu is 30 over standard deviation. Standard deviation is square root of 15. Okay, and then this will be z, and then here will be 32.5. So 32.5 minus 30 over square root 15. Do not forget this square root, yeah? Be very, very, very careful whether you're working with variance or standard deviation. In this case, we need to divide with standard deviation, so do not forget this square root. So if you calculate this one, you will get B negative 0.39 Z and 0.65. So this one, since we have a value of Z of 1 positive and 1 negative, so you can do your the shortcut that I showed in class on Tuesday. So what you need to do is just do 1 minus probability of Z more than 0.39 minus with probability of Z more than 0.65. Okay, or you can also draw your using your normal graph sketch. So you need to find negative between negative 0.9, negative 0.9, and also 0.65. To find this region. Okay, so either you find where you minus everything here, or you can just do the shortcut like this. You do the shortcut, you'll get the answer of 0.3579. Okay, so this is how you do the continuity correction. Okay, that's just an extra step in the beginning. Okay, if you want to do approximation of binomial distribution or a Poisson distribution, so you need to do a continuity correction at first. Okay, in this case, on this part. Okay, this part we do a continuity correction, and then you just proceed as how you usually do. just find the z, okay, z value, and also find the probability, and then you get the final answer. Okay, you can try task 5.7 on your own. Okay, you can pause the video now if you'd like to try. And but what I want you to try actually is task 5.8. Okay, pause the video now. We'll discuss in 5 seconds. Okay, 5 seconds is up. So task 5.8. Okay, for task 5.8, we know that we have 80% of students in a college obtain sponsorship, and then among 150 randomly selected students, and what is the probability that less than 86% of the students obtain sponsorship? Okay, so here we know that this is a binomial distribution. How? Because if we have x, okay, where x is equal to the number of students who obtain scholarship, okay, then x will follow a distribution such that x will follow a binomial, okay, with a probability of 80%. So 80% is 0.8, and we have n equals to, n first, that's for n first, so n is 150, and our pi is 0.8. So if you can see here, your value of n is very big, okay, 150 is very big. So we can approximate using a normal distribution. Just make sure that you actually check the condition first. In this case, that the condition that we need to check is n multiplied by pi. So in this case, 150 multiplied by 0.8. So 150 multiplied by 0.8 is equal to 120. So 120 is way more than 5, so we can approximate using a normal distribution. Okay, so now x will follow a normal distribution of, so our mean will be 150, n multiplied by pi, so it will be 150 multiplied by 0.8, so it will be 120. And for our variance, it will equal to n multiplied by pi multiplied by 1 minus pi. So it will be 150 multiplied by 0.8 multiplied by 0.2. So it will be equal to 24. So your variance will be equal to 24. Okay, so what does the question want? So the question wants us to find the probability that less than 86% obtain sponsorship. Okay, so how are we going to do this? So let's take a look at this first. So less than 86% of the students obtain sponsorship. So what is 86% actually? So you can calculate this. Okay, you can calculate this 86%. So what you can do is just find the number of students. So 86 divided by 100 multiplied by the total number of students is 150. So multiply by 150. To this, you will get the answer of 129 students. Which means what the question wants is actually, so among the 150 randomly selected students, what is the probability that less than 129 students obtain sponsorship? Okay, that's actually what the question wants. There's more work for you lah. You need to find this 86% of the total students. So back to here. So we know that we need to find the probability when x is less than 129. So here, again, do not forget that you need to do a continuity correction first. So if we have x less than 129, so you can draw a number line if you like. Okay, 129, 128, 127, and so on. Okay, so if it's less than 129, not including 129, so it starts at 128, 127, and so on. So if we want to do a continuity correction for 128, So you do 128 plus minus 0.5. So here it will be 128.5, which means if you want to do a continuity correction for px less than 129, so it will become x less than 128.5. Okay, so here you can just continue as usual. You need to convert into z first. So probability of z, so less than, so 128.5. Remember, x minus mu over standard deviation. So our mu is equal to 120. Okay, here is 120. 120 divided by standard deviation. So standard deviation is square root of 24. Okay, so if you calculate this, you will get you need to find the probability when z is less than 1.73. Okay, so from here you can draw your number line. Not your number line. I mean your sketch or graph for the normal distribution. So where is z less than 0.13? Sorry, 1.73. So it'll be here. So it'll be 1.73 over here. So need to find the probability of thing. Okay, you need to find this area, which means what you can do is you need to 1 minus probability when z is more than 1.73. Okay, you need to find the probability over here, and then which is the whole thing, which is 1 minus with the probability more than 1.73, okay, to get this shaded region area. So here it will become 1 minus 0.0418, which equals to 0.9582. Okay, so 0.9582. This is the probability that less than 129 students, or 86% of the students, obtain scholarship. Alright, you can take a break for a bit. Okay, we'll come back in like 5 seconds. You can pause the video now first. Okay, and we are back. So that was for a binomial distribution. Okay, so for this example, x follow a binomial distribution, and then from that binomial distribution, we approximate using a normal distribution. So now we're going to take a look at a Poisson distribution. So we have a question on example 5.3. Example 5.3, suppose in average 100 visitors are recorded to visit a local museum in a month. Okay, the hint here is that it's stated an average, and it is also given as a period. So you know for sure that this will be relating to the Poisson distribution. So let's say calculate the probability that there will be more than 95 visitors in a month. Okay, so let's say that x is the number of visitors, and we know that number of visitors is discrete. Okay, discrete variable, and here we know that x follow a Poisson distribution. So a Poisson distribution have a mean, so our mean here is 100. Okay, our Poisson here mean 100, and the mean of 100 is very big. It is not even in the our Poisson distribution table. Okay, for our Poisson distribution table is not even, there's not even value of lambda equal to 100. The biggest here is 40. Okay, the biggest here is just 40. So what we can do is we should estimate. Okay, not estimate, I mean do the approximation. Where is it? So we know that to approximate to normal distribution, our value of lambda must be more than 20. Okay, we look back here. Our value of lambda must be more than 20. And in our question, our value of lambda is already 100. So it's very big already. So we can just straight away approximate using a normal distribution. So if we approximate using a normal distribution, our mean for our normal distribution would be lambda, which in this case also 100. And our variance will also be equal to lambda. In this case, it will also be 100. Okay, so now x will follow a normal distribution of mean 100 and variance of equal to 100. So now the question wants us to find the probability that there will be more than 95 visitors in a month. So probability that x, okay, x is the number of visitors, that is more than 95. Okay, so here, first of all, make sure you do the continuity correction, because here we have number of visitors. Okay, here we have number of visitors, and we want to convert it into a normal distribution. This will be a continuous distribution. So we want to continuity correct this 95, the value of 95. So if you're still a bit confused, you can draw a number line. So 95, 96, 97, and so on. Okay, so more than 95 means that 95 is not included. So only 96, 97, 98, and so on. So the number that we need to correct is 96. So it will be plus minus. So 96 minus 0.5, it will be 95.5. 5.5 over here. So we need to find all of this lah. Okay, which means it will be x more than 95.5. Okay, and then we can continue as always. So we need to find the z value first. So probability of z, which is will be 95.5 minus with 100. Okay, minus with mu. This is our mu, and our variance is 100. So our standard deviation is square root 100. So here it will be z is more than 0.45. Sorry, negative 0.45. Okay, z is more than negative 0.45. So here you can just draw it. Okay, if z is more than negative 0.45, so negative 0.45 is here. Okay, so you need to know this part. How do you find that one? What you need to do is also equal to 1 minus with probability when z is less than negative 0.45. Okay, we need to the whole thing minus with this part. So you can mirror it. Okay, put it over here. So it will become 1 minus probability when z is more than 0.45. Okay, so it will be 0.45. Here it will be, if you check your normal table, okay, remember that 0.45, check your table, 0.4, and then go to 0.05. So it will be 0.3264. So minus 0.3264, it will become 0.6736. Okay, so this will be the probability that there will be more than 95 visitors in a month. Okay, so I'll give you guys a few minutes or however long that you guys want to continue to task 5.9. Okay, pause the video first here, and then we'll come back in 5 seconds. Okay, so for question 5.9, reading from satellite shows that the average number of forest fire starting point in every 100 square kilometers are 45 points. And then we need to find the probability that at least 120 forest fires starting points in 240 square kilometers. So, so we have x. We have x such that so that x is the number of forest fires starting point. Okay, and this one is in every 100 kilometers square. Okay, forest fire starting point is just like basically in Malay it is called titik panas, where it is just like the place that is more likely, if I'm not mistaken, it is like a place that is more likely for fire to start. So in this case, x is the for every 100 kilometers square. Okay, for every 100 kilometers square, this is the number of place where first fire can start. I believe so. Okay, but that's the more or less the thing here. But this case, it will be discrete because it will be countable, right? The point will be countable. So here we need to find for the question asks us to find the probability that at least 120 forest fires starting points in 240 square kilometers. So for x, first of all, x follow a, this is a Poisson distribution. Okay, now this is a Poisson distribution that follow a mean of 45. Okay, because number of forest fires starting points for every 100 kilometers square is 45 points. So there are 45 different places. Okay, so the question asks to find the probability that at least 120 forest fires starting points in 240 square kilometers. So what you need to do first is, if you forget already about Poisson distribution, okay, refer back to chapter 4. But here we can write a new variable y. So what is y? So y is the number of forest fire starting points, but instead of every 100 kilometers square, we'll now focus on 240 kilometers square, and we'll say a new variable y. So for y now will follow a Poisson distribution with mean equal to what? So we know that for every 100 kilometers square, the mean is 45. So what if about 240 kilometers square? So to find that, we just need to divide, okay, 45 divided by 100, and then multiply by 240. So 45 divided by 100, okay, to get for 1 kilometer square, and then multiply with 240 to get 240 kilometers square. So if you do this, you'll get 108. Okay, which means that y follow a Poisson distribution of 108. Okay, so number of forest fires starting points every 240 square is 100 and okay. So now again here our value of lambda, okay, this is the average, right? 108 is the average, is your lambda. It's very big. If you check your Poisson table, it is not in the table. So since it is very big, we can use an approximation to normal distribution. So here it will be okay, what we want to find is the probability of at least 120 forest fire starting points in 240 square kilometer. So y we need to find more than, okay, or equal to lah, more than or equal to 120. At least 120 forest fire starting points. So it will include 120. So if you want to convert it into a normal distribution, we first must need to know what is the distribution that it follows. So y now want to approximate using a normal distribution. So n will be, sorry, it will follow a normal distribution of, our mu will be 108. Okay, mu is average, which is the same as lambda, and also the same for our variance. So variance will also be 108. Okay, so this will be your normal distribution. So if you want to find the probability of y is more than or equal to 120, so py more than or equal to 120, please make sure to first do the continuity correction. So if you're confused, do the number lines. So 120, 121, 122, and so on. Okay, this one is 119. So here y includes 120, okay, because it's more than or equal to 120. So it includes 120. So it will be 120, 121, 22, and so on. So to continuity correct this 120, we must do plus minus 0.5. So here will be 119.5, which means here it will become 119.5. So now you can just correct it. So you can continue solving by finding the z, the z. Sorry. So z is more than 119.5 minus with our mu. Our mu is 108. 108 divide with standard deviation. So standard deviation is square root 108. So here you will have probability of z more than 1.11, and if you check your normal table, so 1.11 will just be 0.1335. 0.1335. Okay. Alright. So hope that clarifies. Sorry, just going back to the task 5.8 earlier. So for task 5.8, the answer in the book is a bit different, right? So in the book is 0.9591, but my answer here is 0.9582. It's fine, it's just more or less the same. But so if it's in exam, if it's like more or less the same or very very close values, it is still accepted. Okay, because there might be like a rounding off error or something like that. But if it's very close, then I will still accept it as correct. Okay. Alright. So please do more exercise on this one. Okay. On chapter 5. Because now we have finished the entire chapter of chapter 5, and also we have actually finished this whole book. Okay, so congratulations. So just need for you guys to study a bit more, especially on chapter 5, this one. Okay, first of all, let me just hold on. So that's the exercise for chapter 5. Okay, so your exercise for chapter 5, please do it, and you can send it on the Google Classroom. Okay, so I already gave in the WhatsApp group, so you can just refer to this one. I already gave the answer as well, so you can just refer to the answer as well. Okay, if there's any questions, just do let me know. Okay, and that's all for chapter 5, and that's all for this whole syllabus. Okay, again, if you have any questions regarding this chapter or any of the previous chapter, please do let me know. Okay, and if there's nothing else, see you guys in class on Tuesday. Thank you. Thank you for actually listening until this point. Okay, okay, bye bye.